This is Benzaldehyde. It smells kinda like almonds or cherries, and from it I made these two, benzyl alcohol for another video, and benzoic acid, which is being used to treat some skin fungal infections. So the basic idea on how to do it is that I start with sodium hydroxide and benzaldehyde, which then makes those two. But since those two are in a mixture, I'll have to separate them out. To do that, the benzoic acid will be dissolved in water and treated with a concentrated acid, and the benzyl alcohol will be dissolved in diethyl ether, which will then be evaporated off. So to start, I weighed out some sodium hydroxide, 16 grams, and added 16 mils of water to it. Since the reaction is quite exothermic, the mixture heats up a lot. You can even see the steam on the sides of the beaker. So I'll have to wait for everything to cool down a bit before I can proceed to the next step. But when it does cool down, I can pour the concentrated mixture into a bottle together with 20 mils of benzaldehyde. I cap the bottle and then shake it for about 3 minutes to be precise. But this gives me time to talk about the mechanism of the reaction. So I start with benzaldehyde, which is shown here, and a hydroxide ion, so a base. Since the hydroxide is a nucleophile, it will attack the most electropositive carbon in the benzaldehyde, which will result in electrons from a bond, from the double bond, going onto the oxygen atom. So I'll get an O minus, an H on the same atom, and an OH on the same carbon atom. And that reacts with another hydroxide ion, which attacks the OH, which will form some kind of a dianion, which you'll see here has two O minus, let's say, groups on the same carbon atom. So it's shown here. That dianion will then react with another molecule of benzaldehyde that I'm drawing here, and something called hydride transfer will occur where a hydrogen atom goes from the dianion to the benzaldehyde, and the electrons move like so. And what we'll get here is something that looks, or shall I better say, something that is a carboxylate, so COO8, COO minus, and an alkoxide. So it has an O minus and two hydrogens on the same carbon atom. That alkoxide then reacts with the water we added, forming an alcohol, which in this case is our benzyl alcohol, and of course a hydroxide ion. So after shaking it, the mixture has to be let go for a few days.
2 days later.
2 days to be precise. And after that, what I got was this solid white chunk of white, basically. Usually what you get is a porridge-like consistency, but I'm not sure what happened here, and I got a solid block of something. But the next step is to dissolve it in some water. So I had to add 60 mils of water, which is just enough to dissolve it. And then had to shake it a lot. Because it was a single solid piece, I tried breaking it down with a spatula and then shaking it more, a lot more, for 15 minutes. And what I got was this kind of murky solution of benzyl alcohol and benzoic acid, well, sodium benzoate. And since they are together in the solution, I have to separate them. And I'll separate them by extraction with diethyl ether. So to do that, first I'll have to grab a separatory funnel and pour the aqueous solution into it. And to that solution, I'll pour 20 25 milliliters of the diethyl ether. Uh, Benzyl alcohol is more soluble in ether, so it will pass from the aqueous layer into the ether one. You can see me here releasing the pressure in the funnel. That's because ether is very volatile, and if I don't do that, the stopper on the other side of the funnel will go out. Well, it will almost explode and everything will go out. You can see here the layers separating, so the upper ether layer in with the benzyl alcohol and the lower aqueous layer with sodium benzoate. First, I'll separate the lower aqueous layer and wait for it to settle down here. Then do that again, but more slowly. And pour the ether layer into another beaker. It's yellow, although it shouldn't be. I don't know why. That whole procedure has to be repeated 3 times to ensure that almost all of the benzyl alcohol passes from water to the ether. So that was 2, and now this is the third and final time. So what I'm left here is an aqueous solution of sodium benzoate and 2 ether solutions of benzyl alcohol. The first one is a bit yellowish, so I contemplated on whether I should or shouldn't mix them, but in the end I did because most of benzyl alcohol is in the first extract. You can see that it's murky, and that's because there's water in it. So to dry it out, you can see me here adding a bit of anhydrous sodium carbonate, which is hygroscopic, and it will absorb any water that is in the ether layer. After standing for a few minutes, you can see that the solution is much clearer, and I have to separate the sodium carbonate from the ether, and that is done simply by gravity filtration. And after that's filtered, what I have is just a pure solution of benzyl alcohol in ether. And the only thing that's left to do is to evaporate the ether off, and that's done in a water bath, which is possible because ether boils at 30 something degrees Celsius, which is really low. So you can just let the flask out in the open and let the ether evaporate on its own. So what's left is this yellowish benzyl alcohol, which usually is clear and colorless, but I think that's due to my benzaldehyde being a bit yellow. And that's it for the benzyl alcohol. And if you're still here, please consider subscribing if you like this. I have many projects going on. So if you want to see that, please consider subscribing. Now on to the benzoic acid. What I have here is solution of sodium benzoate, and to get the benzoic acid out of it, I just have to treat it with a stronger acid. So a stronger acid than benzoic acid is hydrochloric acid, which I'm pouring here. As I'm doing that, you can immediately see a white precipitate forming, and that basically is our benzoic acid. And I have to keep adding hydrochloric acid until the pH turns around 2, which I'm checking with a pH paper. So I add more and more acid. The mixture heats up a lot, uh, which means that later I'll have to cool it off. And right now you can see that the solution is hot, but it's also pH 2, which means that adding any more acid won't really significantly precipitate out any more benzoic acid. So after it's cooled off, to separate the precipitate, I just have to do a vacuum filtration. Now you could do a normal gravity filtration, but due to the amount of precipitate, it would take literally forever. And usually a rule of thumb is if you want the precipitate, you do a vacuum filtration, and if you want the filtrate, you do a gravity filtration. So after I poured most of the benzoic acid into the funnel, I washed the beaker with a little bit of ice cold water just to pick up some of the benzoic acid that was left in the beaker. And that's basically it for the benzoic acid. Now what's left to do is just to prove that what we got is benzyl alcohol and benzoic acid. Now to do that, for the benzyl alcohol, I'll use something called the Lucas reagent. It's usually zinc chloride dissolved in concentrated hydrochloric acid, but since I don't have zinc chloride, I'll just make my own by reacting elemental zinc with concentrated hydrochloric acid. When I add few drops of benzyl alcohol onto it, immediately the solution should become murky, what you see here. So that means that we proved that we have benzyl alcohol. Now onto the benzoic acid. What acids do is react with sodium bicarbonate or baking soda, forming hydrogen gas. So what I'm making here is a solution of sodium carbonate and adding a bit of benzoic acid into it. If it's an acid, it should form CO2 bubbles, which we see here. So benzoic acid we have. And that's pretty much it, is the Cannizzaro reaction. I've made benzyl alcohol, I've made benzoic acid for future videos, and that's basically it. If you enjoyed it, please consider subscribing, and thanks for watching.